Hi, I'm Liam, and this is my final ISP. This ISP is a basic rocket telemetry project, and it comes in the form of both a device that goes on a model rocket and also this computer-side application that you can see on screen right now. So on the screen we can see the computer application, and this is something that I made in processing. So right now there's no rocket connected, and you can see that by this no serial data connection warning here, but we can still see the basics of how it works. So it's an application that shows you a graph of acceleration over time, and then it will show also velocity, altitude, and then it will show all of them here. And then once the report's over, or once the flight's over, it will tell you a flight report, so the highest altitude and average velocity. And then also a live view shows the live tilt. So I'm going to go ahead and connect the rocket, and we'll get back. Okay, so the rocket's now connected, and I'll go ahead and start the sketch again. And you can see that this time there's no warning saying that there's no connection. We can then go and we can look at the graph of the acceleration, velocity, and altitude, and you can see that the reading is showing here. So yellow is acceleration, red is altitude, and blue, which you can't see, is velocity. So I'm holding it right now in my hands, so there's some slight accelerations. We can see that if I move the rocket, I just moved it up. It had a very big acceleration in the positive direction, and then as it slowed down, it had a negative acceleration, as you would expect. And then I can bring it back down, and you see the opposite happen. And you can see that the velocity and position of the rocket stay pretty much the same because the rocket is in the same place that I first had it. However, I'm going to take the rocket away from where it started, and we'll see that these are going to change. Here's a clip of me using the tilt view the day that I first got it working. You can see that as I move the rocket with my hand, the rocket on screen follows the same movement. Let's talk a little bit about how this project works. So to start off with, all the data gathered for this project comes from a 3-axis accelerometer on the rocket. A 3-axis accelerometer is a device that can measure the acceleration in X, Y, and Z components. The accelerometer used in this project is an ADXL345. A picture is shown on screen right now of what one looks like. This is an I2C device, and it communicates with an onboard Arduino Nano on the rocket. The Nano then finds the acceleration, which is the length of the vector created by all the readings from the accelerometer, as well as the roll and pitch. This roll, pitch, and acceleration data is then sent to the RF communication module on the rocket. This module then transmits this data over the air to the receiver, which is connected to another Arduino Nano. This Nano receives the data and then prints it serially, which is then received by the computer. The computer then uses the roll and pitch information to show that live view from earlier, and it uses the acceleration to both show the acceleration as well as to find the velocity through integration, and to integrate once again to find the altitude. Now, unfortunately, it is illegal to shoot model rockets in the city, and the plan was to do it today, but due to the rain this morning, I never took the trip out of the city, so I have no live launches to show. However, it theoretically all would work. I definitely will take this for a live launch, just because I've already done all the hard work for it, and I want to see it through. So if you are paying attention, you will definitely see that video come up on this channel. I'm not going to make any promises. I think it will likely fail, just because it's my first time doing anything like this, and it generally doesn't go well first times for people. But I hope to learn a lot from it when I do it. Anyways, that's it for now. Thanks for watching.